Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to pick it up from where we left off, okay, on the topic differentiation. In fact, it's limit and differentiation. We are done with limit proper in itself. Okay, so the last lesson that we did, okay, we concluded on limits. We are yet to look at the assignment, the solution to the assignment. And in that case, it means that will be, we'll bring the curtains down on limits totally. However, this lesson that we are going to look at today indirectly has limit in it. So whatever that we did concerning limit, more or less was the basic that will help us, okay, deal with the concept that we are going to learn today. So in today's lesson, we are going to look at what differentiation from the first principles, what we call the crude, okay, differentiation. Okay, we have the refined differentiation, which we'll get to. So differentiation from the first principle. That is the foundation of what? Of differentiation. All right, so please take and stay with me whilst I walk you through, okay, this particular, okay, subtopic or concept. Okay, but once again, don't forget to subscribe, like, and share for more, okay, content of this sort. All right, so we are saying that differentiation from the first principle. So the key word that we have here will be differentiation, then what? First principle. Okay, differentiation, when we talk of differentiation, okay, we are basically looking at in math, we are looking at the rate of change. Differentiation is basically, okay, defined or means, okay, rate of change. So whenever we are differentiating, usually you differentiate a function. So whenever you are differentiating a function, okay, you differentiate with respect to the variable that your function depends on. Okay, so if I'm differentiating with respect to x, okay, then my function is y. Then it means indirectly I'm finding the rate of change of y, okay, with respect to what x. So I'm finding, okay, how y changes when what x what changes. Basically, that's the basic. I mean, that's the meaning of what of differentiation. However, we are going to approach it from the foundation of differentiation, as said earlier. Okay, so quickly let's look at okay this. When it comes to differentiation, anytime you are differentiating a function, you should know, okay, the differential operator, what we call the differential operator. Okay, and like I said, anytime you are differentiating, you have to differentiate with respect to a particular variable because functions, okay, depends on what? Some variables. That's why for every function, you should have an input. So your input, okay, will be the variable that your function depends on. So in any case, let's say if I have y, okay, so let me start from this. Okay, if I have y is equal to maybe 2x plus 1. Obviously, this is a function. You know that usually we say that let y be equal to f of x. So f of x will be equal to y and it will be equal to that. So it means my function y depends on x. So if I have f of maybe z, then it means this x here must change to z. Okay, so the variable that you have in brackets here is telling you the variable that your function depends on, basically. Okay, so I mentioned the differential operator. So because the function f of x, the function y, okay, depends on x. If you are differentiating this function, you can differentiate easily with respect to what your variable x. So anytime you are differentiating with respect to a variable, in this case x, the differential operator will be, take note, d dx. So d over dx, and it is read d dx, not d over dx. Is my point well made, or I should come again?
Please come
Yeah,
again.
please come again.
All right, okay, so we are going to look at how to differentiate functions, okay, but from the first principle. You know, functions are basically expressions with what? With special name. So this is a 2x plus 1 is an expression. Do you agree?
Yes, please.
Okay, so this expression, I can give it y. Okay, name it y. Okay, or name it f of x. Okay, so the expression that I have, you have given it a name, a special name, f of x. And I said the variable that you have in bracket here, okay, basically will tell us that, okay, your function depends on that variable. So this is a constant, this is a constant. So x is the only variable here. So in the same way, like I said, if I have, okay, this is just function, I'm going back a little. So if I have f of w, okay, this will be, I can say that f of w is equal to maybe 3w minus 1. Okay, so because my function depends on w, the only variable that I can introduce here will be w. Any other that you see there will be treated as a constant. Is my point well made now?
Yes.
However, to what we are doing now. Now, anytime you are differentiating, okay, you need to know what we call the differential operator. So if this function depends on x, and I'm differentiating with respect to x, then the differential operator will be d dx. Okay, so in this case, because the function depends on x, I will differentiate with respect to x. So it will be d dx. And I said we don't read it d over dx. You just say d dx. Okay, and it's simply understood to be okay d over what dx. So in this case, if my function depends on w, then if I'm differentiating with respect to w, likewise it will be d okay d what w.
Right.
Do you get the point?
Yes, please.
So the variable that you have here in the denominator will tell us the variable that you are differentiating the function with respect to. And it will always be the variable that your function depends on, like I said. Okay, but we need to know, okay, some special notation. So if I have, okay, y, the function y, and I'm differentiating y with respect to what x, it means I'm taking d dx of what of y. And if you have d dx of y, it's simply written as what dy dx. I believe some of you have come across this. Okay, is there anyone who has come across this? Here.
Yes, please.
Okay, so indirectly, I'm giving you, okay, what that means. So if I have a y and I find d dx of y, okay, we don't write it d dx of y, okay, but it's simply written as dy dx. So remember, I have told you we don't, okay, mention the bar, the division bar that we have here when we are reading it. Okay, so this is dy dx. This is d dx of y. D dx. So this, in actual fact, is your operator. Your operator will affect what? A function. So your operator must always affect what? A function. The function could be y, it could be f of s, it could be g of s, it could be h of s. You've done function. Okay, we know how we label function. So in the same way, if let's say I have a function, let's say q, or let me say j. Okay, j, okay, of x is equal to maybe whichever. Okay, and I'm finding, okay, let me even still go by the y. Okay, let me start with the y. I'll come to the function with its name. If I have y, okay, to be equal to maybe, okay, let me use, okay, 4z minus maybe 3. Okay, this function y depends on what? On z. So once it depends on x, then it means if I'm differentiating y, I have to differentiate with respect to z. So my differential operator will be d dz. But it will be d dz of what? Of y. Okay, and d dz of y becomes what? dy what? dz. In short. Is my point well made? Or I should come again still?
Yes, please come again.
All right, no P. All right, no problem at all. Okay, so your foundation. And as for calculus, okay, I have to make sure that you understand it perfectly. Because a course student, if you want to pursue, okay, a course math, engineering, okay, anything concerning math in the near future, okay, it will involve calculus. So please take notes. Okay, so we'll come to its application and I will take it maybe subject by subject for you to know. All right, so in this case, let me clear this, whatever that you have here, and see if I can take another direction, make my points again, then we'll be good to go. So what basically I'm trying to do is to introduce you to the notation, okay, of differentiation, because we'll use it in quoting the formula for the first principle differentiation. Okay, so if you don't get the notation, if I quote it, you wouldn't appreciate. Okay, so this is what I'm trying to say. So if I have my operator, now you agree that the differential operator, if the function depends on x, my differential, and I'm asked to differentiate with respect to x, my differential operator, you agree that will be d dx. That one we are all fine, right?
Yes, please.
Okay, so this is your operator. Okay, you know, anytime, even in basic school, okay, when we mention operator, any operation will not function in vacuum. Okay, you won't see it standing on its own. It will always affect something. I hope you get my point. In any
Yes,
case, when you
please.
were doing function, you know that composite function, even function, we're dealing with what? An operation machine. So there was an operator. And maybe the operator will be maybe f. So it will be f, then you feed it with x, and that will give you an f of x. So your operator, if I'm talking, so if I take this, I have my operator f, okay, then I'll feed it with x, and that will give me the result, okay, that I have here. So that's the meaning. So in differentiation, this is the operator. The operator, like I said, okay, does not occur in isolation. It should affect, okay, functions, relations. Okay, so if my operator is affecting y, okay, so I'm taking d dx of what? Of y, meaning I'm differentiating the function y here with respect to x. Okay, its notation, this we don't write it d dx of y. We write it, okay, maturely as what? dy, okay, dx. So in the same way, if I have d dx, okay, of z, okay, this will be equal to what? Dz
Boy. ADX, rather.
dx. Do you get my point now? I hope you are
Yes,
getting it
please.
gradually.
Yes,
Yes,
please.
please.
Okay, so it's the notation that I'm introducing you to. So anytime you see maybe dy, dx, okay, the operator is this, and the function that you are differentiating is y. So that is what the operator is always, okay, what is affecting the function that you are differentiating. Okay, Prof. Caroline.
Mr. Hackman,
Okay.
please these please the DZ and the X. Please,
Mhm.
if you are trying to write its function, please will it be like fx is equal to z, like z is equal to 2x plus 1.
No, once I say I'm differentiating, so it means the function that I have there, I have labeled it as z. So it means I'm using this as a particular example. That doesn't mean my function will always be 2x plus 1. I hope you get it.
Yes, please.
Okay, so there's a particular. So once I am saying that my function, once I've called my function z, so that's the more reason why I'm differentiating my function z with respect. So it means in this case, instead of y, this will be z.
So please that's what I just said.
Okay, is that what you said?
Yes, please. I
Okay,
was
then
trying to say that the D
okay,
replace
then
the
maybe
Y.
I didn't get you well. Okay, okay, my bad.
Okay,
Okay, forgive me. All right, so that's it. So it means this time
okay.
round, your function, its name is no more y, but it is what? It is what z. It's my point well made.
Yes,
Okay,
please.
but only that you know that usually functions are represented by y. That's why we say let f of s be equal to y, not any other. I hope you get my point. But this is just
Yes,
for you
please.
to know that your function, I didn't say always, usually. You can name it any, give it any a letter name. Okay, all right. So it means in the same way. So now, if you know, if I'm finding d, okay, dx, okay, of let's say y, we know that this will give us what? Per what we have so far. That's what I want you to know first of all. D dx of y will give us mhm,
DDX of Y will give us the X dy.
no.
No,
DY,
dy dx,
DX.
rather.
dy dx is even on the board, dy dx. Is that
Yes,
clear, my
please.
professors?
Yes.
Yes,
Okay, that
please.
is one. Okay, that's one notation. So that is if the function comes with the name y. But the function can also come with the name f of s, g of s, what have you. The usual function names. Is that clear?
Yes, please.
So if the function comes with what? The name, okay, so let me start from here. If it doesn't go there, I will come down. So if the function comes with f of x, And you are still, because the function depends on x, okay, you differentiate with respect to x. So what will be your operator that will affect this? That will be d dx. You get it? Are you with me? So if I have this
Yes.
function and I want to differentiate with respect to x, then it means my differential operator will be d dx of this function. Is that clear? Just as if you have y, the operator, and we are differentiating with respect to x, your operator is d dx. Is my point well? So my d dx, my operator, is affecting this function, just as your operator was affecting this function, and it gave you a result.
Yes.
Okay, it's what notation, proper notation. My professors, are you with me?
Yes, please.
Okay, however, okay, let's see, ordinarily, based on what I've taught you, okay, if you were supposed to predict, okay, what will you write? This will be equal to what? If d dx of y is equal to dy dx, then d dx of f of s will be equal to, ordinarily. Now, professors, oh, can't you make a guess? At least you should be able to get. Okay, so let's see. If d dx, okay, of y, okay, is equal to dy dz. So now maybe you see the pattern. Okay, sorry, dx, forgive me. If d dx, okay, of z is equal to dz dx. Do you agree?
Yes,
Yes,
please.
please.
Okay, and d dx, okay, of w will be equal to what?
UWDX.
DWDX.
Okay, dw dx. Is that not it?
Yes, please.
Yes,
Okay,
Yes,
so
please.
please.
once you see the pattern, if I have d dx of f of x, what do you think that will be if I'm supposed to follow that pattern?
UDX of X. No, DDX of F of X.
No, say it well. You know that always you
D,
attach this. So whatever you have here today, so it will be d,
DX of
no,
F of
d,
X.
DDF of
no,
DDF of X.
d
DD
what?
EFX.
DD
Yes.
D
No, 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 you're lost. Oh, interesting. I'm enjoying the class. All right. Okay. So let's see. Maybe I'll start calling you. Okay. I want you to. Okay. You can say it's okay to my hearing. I'll start calling you. Okay. So if d. Okay. Take notes. Okay. If d dx of y is dy dx. Okay. D. Okay. Sorry. D dx of z is equal to dz dx. D dx of w is equal to dw, okay, dx. I hope you see. So when you are mentioning it this way, you are combining. It will be dy dx. Okay, but if you are saying it this way, it will be d dx of y, d dx of z, d dx of w, which is giving us d dz of d dz of what dx. You infected me with the way you were mentioning
DFX
dx.
DX.
Hey, so hey, come again.
DFX DX.
Very good. Okay, dfx dx. Is that not it?
Yes,
Yes,
please.
please.
So whatever you have here will be attached to this. So it will be dfx, okay, dx. Is that clear?
Yes.
Yes, please.
However, we don't write it this way. Okay, we have a better notation for it, and this will be equal to f prime of x. So anytime you see a function with a prime, it's trying to tell you that that function has been differentiated. Okay, and that's the first derivative. If you see prime, it means it has been differentiated one. It means your differential operator was used once. Okay, you can see prime prime, then it means that function has been differentiated twice. Should I come again or my point is made?
Please come again.
Okay, all that I want you to know is the notation because I'm
Come
going to
again.
use that notation, okay, and attach a particular formula when we talk about the first principle. Don't worry, okay, I got you covered. So let's see, let me clear that. I've told you until your foundation, you get the notation, we are not moving. So we have to make sure we get the notation before we start moving. So let me clear then come again. All right, please make sure you get it. Okay,
Yes, please.
all right. So before we move on, okay, once I know you will need it and you've not been taught, if I'm spending the whole day for you to get it out, but once you've been taught, okay, usually I will encourage you to be drawing us back. So I'll ask you to go and revise because maths will build on. Okay, so this is what I'm trying to say. Now, indirectly, we know, okay, as for when it is Y, when it is whichever name, okay, apart from, we know, okay, if it is Y, dx, the operator is ddx, okay, of Y will give us what? Dy dx. So that is what I want you to know. Okay, and you said that one you've known. Now we are looking at if the function comes with its own name, f of x, g of x, the usual names. So if I have f of x. Okay, my operator, because the function depends on x, I can differentiate with respect to x. And if I'm differentiating with respect to x, that tells me that my operator is what? D dx. So I'm finding d dx of what? F of x. And I'm saying that d dx of f of x, okay, has what? Its own notation, its meaning. Okay, you don't write this time, you don't write it as d f of x, okay, dx, but you rather, okay, write it as f prime of x. Okay, that's all that I want you to know. It's a notation. Okay, more or less a symbol representing something. Okay, so I just want, so it means if I have d, okay, dx, okay, of what, j of x, what do you think that will be?
J prime of
J
D
prime of, j
J
prime of
prime X
x. Okay, so if I have d dx, okay, of h of x, that will be equal to
H prime
H
X.
prime of
h prime
x.
of x. My professors, I hope you are getting it
Yes,
now.
please.
Yes, please.
It's just a notation that I'm introducing you to. Okay, it's nothing, we are not using any formula. Okay, so that if you see this notation, you know what it represents. That's all. Okay, Prof. Nana Kwame.
Yeah, so assuming f of x equals y, does that mean that the y dx equals f prime of x?
Here is the same. Yes. If you use f prime of x, if the function came as f of x to represent its differential, and you use dy dx if the function came as y. So if the function came as y and I asked you to differentiate with respect to what? I mean x from the first principle, then you should know that I'm asking you to find dy dx.
Okay, sir.
Okay, and in the same way, if the function came with the name f of x and I asked you to differentiate that function, okay, from the first principle, you should know that I'm asking you to find f prime of x instead of dy dx. They are the same, but you can see that because the function has a name f of x, if you are concluding, you cannot use y for it. Because if you use y, then it means you have, okay, represented the function by y. And you remember I told you, you can, anytime you represent something by, you cannot conclude with it. You introduce your own variable, you don't conclude with it. So if the function came as y, it will be dy dx that you are asked to find. If the function came as what? As f of x, then it means you are asked to find f prime of x if you are asked to differentiate once. Afa, please, is everyone on board now with the notations? Are we
Yes,
all fine with the
please.
notation?
Yes. Yes.
Okay, so once you are okay with the notation, then I'm going to introduce you to the formula for finding, okay, the first principle differentiation. Okay, at the normal circumstance, I should have, okay, taken you through, okay, how the formula was arrived at. Okay, but that will take our time. Maybe possibly when you are in school, your various teachers will, okay, do that. Okay, all right. Okay, so quickly let me, okay, do this, then I'll be back. Okay. All right. So now I'm going to introduce you to the differentiation from the first principle. And I was saying that, okay, at the normal circumstance, I should have taken you through how, okay, this formula was arrived at. Okay, but I've told you when you go back to your school, your teachers will do that. What you need to know is how, okay, to quote the formula and how to use the formula. And that's going to be my target, okay, today. So that will be our objective. Okay, so from the first principle, usually this is what you are from. Okay, the first principles. Okay, so if your function came as y, then you know if you are differentiating, okay, the function with respect to x, it means you are supposed to find dy, okay, dx. Okay, which should be equal to, if the function came as f of x, okay, and you are differentiating that function with respect to x, then you know that will give us f prime of x. Is that okay? My professors, are you with me? Or I should come again?
Please
Yeah,
come
please come
again.
again.
Okay, so it's just, I'm trying to say that dy dx, okay, if you have dy dx, then it means the name of the function was y, and you were asked to differentiate with respect to, I mean, from the first principle with respect, so it means the question exactly need to find dy dx. And if your function came as what, f of x, then it will be what, you are finding ddx of f of x, which we know it will give us what, f prime of x from where we are coming from. Is that okay? So
Yes,
this and
please.
this, we
Okay.
now know they are the same. Okay, only that you use this if the question, okay, the function came with the name f of x. You use this if the function comes with the name what, y. Okay, Prof. Angie.
Uh, Please, can we just maybe always we'll just like make f of x equal y, so we'll end up using dy dx
Okay,
always
so
instead
yeah,
of
you can do
using
that, but you cannot conclude with what? With dy dx. So you still have to conclude involving f of x if the function came as f of x. So if I ask you to find, I give you f of x is equal to, and you represent, okay, y or f of x be equal to y. You cannot say that therefore dy dx because I didn't give you y. So you have to conclude with this instead of this. So that's the more reason why I am taking you through, okay, each of them so that if it comes in y, this is how you conclude. If, I mean, what you use in drawing your conclusion, if it comes in f of x, this is what you do. Do you get the point?
please understand. Yes, please.
Okay, all right. And now here comes the formula. So this will be equal to, so please take note, this is now the formula. Okay, so the limit, so you can see the limit in play. As h approaches 0, okay, off, so you are going to have, okay, a rational function. That will give you f of x plus h. I will explain, don't worry, minus f of x is just a formula. Just learn how to quote it. I will guide you as to how to use this over h. Oops. Okay, so this is the formula. Okay, like I told you, ordinarily we should have gone through how to, okay, derive this formula, or how this formula was, okay, derived. Then you know, so the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so that is all that you need to know. We'll be quoting this formula often. So either consciously or unconsciously, it will stick. So don't worry at all. So it means if you're, okay, we'll be working with the example. So if your function came as y, then you will say that from the first principle, dy dx is equal to this. You don't write this. If your function came as f of x, you write from the first principle, f prime of x is equal to this. You don't write this. Do you get the point? My professors, are you with me?
Yes, please.
Are, are you all with me? Or I should come again?
Yes, please. Please come again.
Okay, don't worry. I will come again when we are looking at the work example. So let's move on to the work example. Okay, then I'll make my point. Okay, so this is, it's not difficult at all. Okay, it's not difficult. It's just a formula. Quote the formula, and okay, the formula will guide you as to what to do. So now let's see. Differentiate the following from the first principles. So you underline this critical. If you use any other approach, you'll be marked down. Okay, so now solution is what you write first after you have underlined the salient part. The next thing that you write is the major question number, if there is, and here there is a major question number. Then you come to your minor question number, that is I. All correct. Okay, so
Yes, please.
you extract what you are giving. So what am I giving? I'm giving y is equal to what? 7x. Okay, so you can see that here, okay, the function has a name y, not f of x. Is that clear?
Yes, please.
So if I'm quoting the formula, that's the first principle formula, this is what I'm going to do. So I'll write from the first principle, okay, comma. Now, because my function came as y, if I'm asked to differentiate this with respect to x, it means I'm finding d dx of y, which will end up giving me dy dx. So I'll write dy dx, okay, is equal to, I won't come and write the f prime of x because the function didn't come in terms of f of x. So it will be equal to, I quote the formula, so it will be limit as h approaches 0, okay, of what? So the numerator will be f of x plus h, okay, minus what? F of x, okay, all over h. All correct, my professors.
Yes.
Hello, I hope you are gradually getting on board. We will solve more examples, so you will be compelled to come on board, even if you are reluctant. Okay, to come on board, you definitely, okay, come on board. Okay, Prof. Gideon.
So please, is it necessary to use it, or you can use any letter?
Okay, you can use any letter. Okay, only that usually we use H. You can use any letter apart from Y and X. Okay, the letters that you have there in your, okay, you can use any letter apart from these two, or most
Okay,
especially
I'm
X.
talking about,
So you can use
I'm
A.
talking about okay, sir.
You can use A, you can use whatever. So if you use A here, then it means this must be A, this also must be A. But the usual one that we quote, okay, will be the one involving H. So that's what you most often than not see in your various textbooks. Is that clear? Benjamin.
Sir, please, I can't see the handwriting.
Okay, Mama, you can hear, right? You can hear, right? Benji, can you hear?
Yes, please.
So if you
Yes,
can
please.
hear, then you should be able to relate. Because whatever that I write, I say it. So it will be f of x.
Okay, sir.
Okay, so
Sir, and
try
the
to
first one
connect.
is f of s.
F of
The
x
first one
plus
is
h.
f of s plus h.
H, yes.
Okay, sir.
All right, okay. All right, so now this is what we do. We've quoted the formula, we know the formula. So let the formula talk to us, guide us as to what we are supposed to do. Okay, so in this formula, this is what the formula is telling us to do. Okay, we need to subtract f of s from f of s plus h. And you know that for every function, the parent function is f of x. So we need to go and get a representation for f of x, which we all know f of s will be the same as y, but we are going to let f of s be equal to what? Y. So this is what you do from here, having listened to. So if I know f of s, I should be able to find f of anything. So just listen at this point. Don't write. Maximum attention. Full attention. So I'll write let's, okay, y be equal to what? F of x. Or let me even write f of x. The same thing anyway. But I want to let f of x be equal to y. It's the same thing. So f of x, okay, be equal to what? Y. So it means that my f of x is equal to what? 7x. Do you agree? My professors, are you with me?
Yes, sir.
Okay, now you know if I know f of x, I know f of s plus h. Because if you know f of x is equal to, from the function perspective, if f of x is equal to 2x plus 1, and you are asked to find f of 1, what do? This will be equal to, wherever you see x in f of s, you place it with 1. Is that not it?
Yes, please.
So that will give us 2 into 1 plus
Plus.
1. My professors, I hope you are with me.
Yes,
Yes,
please.
Okay, so if I know f of x and I'm going to find f of x plus h, it means wherever I see x in f of x, it is now s plus h. Do you agree now?
Yes, please.
Okay,
yes,
so it means
please.
this will be equal to 7. Wherever I see x here, it becomes s plus h, so into s plus h. All correct.
Yes, please.
Hello, who wants me to come again?
Sir, please me.
Okay, don't worry. Okay, so remember I've told you this is the foundation. So if you don't get it, the future will be very bleak. Okay, Prof. JJ, Prof. Jermaine. Please unmute and talk. Okay, let me see the other person. It seems. Okay, Prof. Kenneth.
Please, I don't understand the f of x is equal to 7x. I don't
Okay,
understand.
okay. So you let f of x be equal to y. So this implies what is y?
7x.
Do you get it? You've done functions, right?
Yes, sir.
And functions, you've done inverse of function. When you were doing inverse of function, you know usually, right, let y be equal to f of x. You get it? Then it means y is equal to the name of the function given. So it's the same thing. Let f of x be equal to y. So it means f of x will be equal to, what is y? 7x. Is it clear now?
Yes, sir.
Okay, all right. So now that you know f of x, you are more than able to find f of x plus h, meaning your new input is what? X plus h. So wherever you see x here is x plus h. And because it's a binomial, you put it in bracket. So can I say that what I have here will be equal to, usually you write close to the margin, but I'm writing it going forward, I will do the right thing. So that will give us what? 7x, okay, plus what? 7h. Do you agree? My professors, are you with me?
Yes,
Yes, please.
please.
Okay, so now you know f of x, you know f of x plus h. So you just go and substitute. Okay, so at this point, I'm going to write this. Okay, so I'll go and substitute. So I'll come and write because something has interfered. Okay, with the left-hand side, I cannot straight away come and write equal to and substitute. What is equal to? I have a whole lot of that about. So I'll have to come and write, okay, this implies, or if I'm mature, this is the first one. So I'll come and write implies. Maturedly, I'll write therefore. So dy, okay, dx. I'm going to substitute will be equal to the limit as h approaches 0. Okay, of your numerator, we said is f of s plus h, and that is what? 7x, okay, plus 7h. Do you agree, my professors?
Yes, please.
Minus, what
Yes,
is your
please.
f of x?
Move x is 7x.
7x, but it's just a term, so I don't have to put it in brackets. So 7x.
Yes,
Okay, all over h.
h.
My professors, are you with me?
Yes, please.
Okay, great. Okay, please, is everyone on board at this point? This is the very first example. And that one even involve only one term. Okay, all right. So now it's just quote the formula. Okay, come and find f of x plus h, then go and substitute. Okay, so at that point, let me go and clear what we have here. This has served its purpose. Oops, okay, so let me clear here. Okay, so let's go. All right, so now we are going to get, okay, that will be equal to, that is my d, nothing as dy dx, okay, will be equal to the limit as h approaches 0. Okay, your numerator, can you simplify? You know that your numerator will give you 7h. Do you agree?
Yes, please.
Okay, all over h. My professors, I hope you are with me.
Yes, please.
Okay, so this will be equal to, the h will cancel. Okay, so you're going to get the limit as h approaches 0 of 7. Do you agree?
Yes, please.
Okay, the limit of a constant is
A constant, so
a
7.
constant, so it means this will be 7. All correct, my professors?
Yes, please.
Okay,
Yes,
so
please.
now I'm drawing my conclusion. I was asked to differentiate y with respect to x from the first principle, or differentiate y from the first. So I'll write therefore, okay, dy dx, okay, is equal to 7. Okay, so ordinarily, when you are matured, you can come and write your therefore here, so that when you end at 7, your conclusion is embedded in your steps, just like I've been doing. Is that clear, my professors?
Yes, please.
Okay,
Yes,
we'll do
please.
more. Don't worry, you will get it. At least the first 3 examples here, everyone must come on board before we go and look at, okay, complex, okay, functions. a little more complex functions. Okay, so this is the first example. Now I'm moving from I to II. Okay, so II, what are we giving? We are giving f of x, okay, is equal to what?
X plus
X
5.
plus 5. Okay. Okay, we need to differentiate this from the first principle. So as you mature, okay, you can choose not to write the first principle, just quote the formula. Okay, we know that that's the formula for the first principle. So I'm going to deal with it maturely now. Okay, so at this point, this is what we are going to do. Okay, so we are going to quote the formula. And the formula, because the function came in f of x, we won't write dy dx, because if you are asked to differentiate f of x, it means you are finding d dx of f of x, which we know will give us the notation f prime of x. Do you agree?
Yes, please.
So it means I'll write f prime of x will be equal to, then go and quote the formula. So the limit, okay, as h approaches 0, okay, of what? Let's quote it. F of x plus h,
F of
X
x
plus H
minus
minus
f of
minus
x minus fx
is that all over
all over h.
h. Safa.
yes, please.
Yes,
Okay.
please.
So
No, sir,
now,
please. So no matter how like you get it, maybe F prime. From the first one, we didn't get the F prime or whatever.
yes,
So
the
it
first,
will be the same formula
yeah, it will be the same formula, like I said. It's the same
for all
formula,
of
only
them.
that, okay, yeah, all of them, it will be the same formula that you quote. Okay, only that what you have here will change depending on the name of the expression or the function. So that's why if you
Yes,
go to what I have there, let me go back. You can see that I said dy dx. So if you use dy, then it means the name of the function was y. So therefore, if you are differentiating that function, you get dy dx, and it will be equal to this formula. If the function is f of x, if we are differentiating a function f of x with respect to s, remember we said if I have d ds of f of x, that will give me f prime of x. So it means my result, which is f prime of x, will be given by this formula. Do you get it now?
yes, please. Thank you, sir.
You are welcome. Okay, I saw another hand. Carol, were you the one?
Yes, please. So please, you've answered my question.
Okay, all right. Okay, so now, okay, let's go. So you listen to the formula. Now that you quoted the formula, let the formula talk to you. Okay, so in this formula, I need to go and find f of s. Do I know f of s directly? Yes. This one is no, so you won't do any let. So once I know f of s directly, I can go and find f of s plus h. Do you get a point?
Yes, please.
Yes.
So now I'm going to write but, or you can use implies. Okay, f of x plus h will mean wherever we see x in f of s, we put s plus h there. Do you agree?
Whenever
Yes,
you
please.
see,
Wherever you see x in f of x, if you have f of x and I ask you to find f of 1, okay, that's your parent function, f of x. If you ask to find f of y, it means wherever you see x in f of s, you put 1 there. Is that not it?
yes,
So
please.
now our new input is s plus h. So wherever I see x here, I put s plus h because this is now s plus h. Do you get the point now?
Yes, please.
Okay, so I am going to get,
No, please.
okay, if you are, this is just functional. So let me quickly see. If I have f of x is equal to 3x, and I ask you to find f of 1, what will you do?
It's going to be 3 into bracket 1.
Okay,
You
then you go,
substitute x.
yeah, then you go and find, if
1.
I ask you to find f of 2, what will you do?
3 into bracket 2.
2. Okay, so 3 into bracket 2. If I ask you to find f of w, what will you do?
And
AW.
3 into
into
w. Is
bracket
that
W.
not it?
Yes,
Yes.
please.
Okay, so you remember when we did function, we did function evaluated at specific value, and I taught you how to evaluate functions also at expressions. So now you are evaluating your function at an expression s plus h. So it means wherever I see, okay, my x, I put s plus h there. Do you get it now? That's my new input.
Yes, please.
Okay, so wherever I see x here, okay, I put, okay, s plus h. So that will give us, okay, s plus h. I'm putting it in brackets, okay, then plus 5. Do you agree?
Yes, please.
Okay, so that will be equal to, if I continue, I'll come close to the margin. So that will be equal to always remove the brackets before you go and substitute. So that's the first advice. So if I remove the brackets, I'm going to get f plus h, okay, plus 5. Someone who is matured, okay, can write this one here straight away because the person will know that the brackets will not be necessary here because you will end up getting the same result. Is that clear? So
Yes,
basically,
please.
what I've written here is for explanation purposes. All correct?
Yes, please.
So now we know f of x. We equally know f of x plus h. So we can go and carry out our substitution. All correct.
Yes, please.
So when I'm carrying out my substitution, I will draw my conclusions. I'll come and write, therefore, f prime of x is equal to then. So that's how I'm going to proceed. So I will move on to the next page. Let's go. So I'll write, therefore, okay, f prime of x, because the function came as f of x and I'm asked to differentiate, my result will be f of f prime of x. That's what the question is looking for. So the limit as h approaches 0, then we go and carry out our substitution. The denominator will be h. Okay, so the numerator, we said f of x plus h gave us what? X, okay, plus h plus 5. All correct.
Yes,
Yes,
please.
please.
Then minus f of x. F of x gave us, f of x is x
X
plus 5.
plus 5.
Now, because it's a binomial and it comes after the subtraction, okay, we are compelled to put it in bracket. All correct. Other than that, the meaning changes.
Yes, please.
My professor, is everyone with me?
Yes, sir.
So after substitution, you go and simplify the numerator, just as we did in the first example, the I. So my next step equal to, okay, I'll write the limit. Remember, I'm not carrying out the substitution, so the limit cannot go. We know how to deal with limits. We are experts, or we should be experts, okay, for now. So I will simplify my numerator. So the denominator will be intact, which is the h. Numerator will give me x plus h, okay, plus 5. Then now minus x minus 5. All correct.
Yes, please.
Okay, so this in effect will be equal to, still I'm simplifying my numerator. I'm not, okay, carrying out my substitution. So the limit as h approaches 0 shouldn't vanish, cannot. So minus s will cancel the x here. Minus 5 will cancel the plus 5. So I will get
H on H.
h on h. Professors, are we fine?
Yes,
Yes,
please.
Okay, h on h is the same as
1.
1. Okay, so
1.
we are going to get the limit as h approaches 0 of Ekome 1. Okay. So the limit of a constant again is a constant. So this will give us 1.
1.
Alpha.
Yes, please.
Okay, so
Yes,
take
please.
note. Here I've drawn my conclusion. My conclusion is embedded. If you didn't write therefore here and you wrote implication, then you are now going to write therefore f prime of x is equal to 1. Alpha.
Yes, please.
Okay,
Yes,
Yes,
please.
please.
down to the third one, I. Hello, my professors. Any question before we go and look at the I? Okay, Prof. Frank. Prof. Frank, go ahead. You have the floor. Oh, okay. All right. So I don't know what is happening with the audio. Okay, so we can't wait for you forever. So fix your audio, then come back. Okay, so I. So at that point, I leave a line before I come in to my sub question. You know this particular rule. So what are we giving? We are giving, okay, f of x
Of X is equal
It's
to
is
equal to
2X
equal to,
minus
2x
3.
minus 3.
okay, 2x, okay, minus 3. So we quote the formula, is that not it? Because we know that
Yes,
first
please.
principle involves the formula. So always quote the formula, okay, let the formula guide you.
Please.
Okay, so as you mature, for me, I am matured, and because I know that the formula will involve f of x plus h, I can come and find f of x plus h before going to quote the formula. Okay, it doesn't really matter how, okay, you arrange, but my advice is quote the formula and let the formula guide you. Okay, when you are mature, you can do you can vary your presentation. Okay, so in this case, instead of writing from the first principle, I'll write, okay, dy dx is equal to, am I right?
Yes, please.
Hey.
No, please.
No,
It's
sir.
going to be f prime of
F
x.
prime x.
F prime of
F
x,
So
prime
very
x
good. It's
yes,
not
is
F
please.
equal
prime
to
x,
Which
lim
is
it's F
h
prime of
ma-
x. It's
F
not F,
prime of x.
f
F
prime
prime
of
x
x.
is this. Okay, so
No,
take
f prime
Okay.
note.
of x.
So it will
F
be
prime
F
of
prime
x.
of x, okay. So let me, or if you like, because you are quoting a formula, you can write that here, or you can ignore. So, but F prime of x will be equal to
Equal to lim
h
X
approaches zero
approaching h is 0. Yeah,
eh,
that's all right.
approaching 0
of
is
what?
equal to f
F
of
into
x plus
brackets.
h
Plus h, sorry.
minus f of x all over h.
Formula nafa. Okay,
Um,
formula na pick it. All right, okay, so now this is what we have. So, like I said, okay, in math, it's not every formula that you must consciously just work with it unconsciously. Okay, all right. So sometimes that's how the brain works. So now, okay, having quoted the formula, okay, we ask ourselves, this formula, I need to know f of s. Do I know? Yes, it's given directly. Okay, I need to know f of s plus h. It's not given directly, but once I know f of s, I can go and find f of s plus h. Okay, so I am good to go. So now what do I write? Again, I can write f of x plus h. Okay, I will need it. Okay, but f of x plus h will be equal to, let's go. Wherever I see x in f of s, it is
2
s plus h. So it will be
2
2 in brackets
of
s plus h. Do you agree?
plus a minus 3. Yes,
Minus 3.
please.
Hello, who wants me to come again, my professors? Are you all fine? Who wants me to come again?
Me.
Hey, Prof. Buddy. All right, from where? It kept long in coming. Hey, from where? So those who get it, you can proceed
Please from the back.
from the bat. Which bat? Okay, this bat. This bat. This bat, there you were just quoting the formula that you put in here. So if you are lost here, then it means you are lost here as well. So but you come in, because we are giving f of x, if you are differentiating with respect to x or differentiating from the first principle, you get f prime of x equal to, go and quote the formula. This is the formula. You quoted the formula for this one, okay, the one before. So this one, you shouldn't have any problem. It's just a formula that you are quoting. That's all. So this one has no input. It's just a formula that you've been given. Just quote it. That's all. Okay, Prof. Martin.
so please, I'm trying to confirm something.
Uh-huh.
So if you're having a function 2x, right? A function f of x that is equal to 2x. The 2 there refers to the f, like is for the f, and then the x is the variable which f is
Oh,
dependent.
not confirmed. Not confirmed at all. Okay, so this is it. Okay, take note from functions. Okay, function is just an expression with a name. So this is an expression with a name. The S is trying to tell you that the function depends on S. So if I'm labeling the function, I cannot call this f of y. I can only call it f of z.
Yes, please.
So the whole
Yes,
of this is
please.
your f of s, not that this is your f. Okay, so if this is your f and this is your s, then what is this? What is the minus 3? You get it?
Yes, please.
Okay, all right. So please, Prof. Martin, as for functions there, what I'll see you when I taught you. So if you need to revise, go and revise. You know,
Yes,
math we
please.
don't on. And here too, I take my time and teach you. So something
Yes,
that I've
please.
taught you, and I always tell you that in math, it's not all topics that you understand. So the one that you are taught and you really understand, don't let it leave you. Always make
Yes,
sure you
please.
revise, okay, and you keep your understanding up there. Okay, the one that you don't understand, that's where you have to, okay, give it more time. But the one that you understand, please don't let it leave you. So at this point, you all agree this is it. And remember, I told you before you go and substitute, expand. So it means I'm going to expand that, which will give me 2x plus 2h, okay, minus 3. All
Minus
correct.
3. Yes, please.
Okay, so now I know f of x. I found f of x plus a, so I'm more than good to go. So therefore, what I was asked to find, I was asked to differentiate f of x. Okay, so it means I need to find f prime of x. Okay, and that will be equal to, so the limit. So I just come and substitute that into my formula. So I'm dealing with the formula there. So the limit as h approaches, okay, 0 of what? My numerator we said is f of s plus h, which is what? 2x
2x plus
plus
2h minus 3.
minus 3. Okay, minus f of x. And f of x is a binomial.
2x minus 3.
So you put the whole of the binomial in bracket. Failure to put it in bracket, okay, we m0, it will be very costly, a0 going forward. So all over h, don't forget. All correct, my professors.
Yes, please.
Okay, so now I know the next thing that ordinarily I would have written my equal to here, but remember the advice, always write close to the margin. So I'll come close to the margin, then come and write my equal to what I would have put here. Then I'll write lim h approaches 0 again. Okay, of what? I go and expand my numerator. So, okay, denominator h will be there. So I'll always write the one that will involve little or no input before I come in. 2x, and let's go. Plus 2h, help me. Minus 3 minus
2
plus 3.
minus 3.
Hey,
Plus 3.
plus 3.
Plus
All
3
right.
plus
Okay, all right. Because you can't change it. So you have to be very careful. All right, so this will be equal to, okay, the limits. We are still simplifying the numerator as h approaches 0. Okay, our numerator now will be, okay, 2x will come, minus 2x will take care of the 2x. Then minus 3 and the plus 3 will go. So we get 2h, all correct?
yes,
2h
please.
over h, yes, please.
Over
Over
h, which
8.
will give us the limit. Okay, as h approaches 0 of what? 2. And the limit of a constant is a constant. So this will give us what? 2.
2.
Alpha.
Yes, please.
Okay,
Yes,
so
please.
first set of examples. Okay, well understood. Are we all fine? Prof.
Yes,
Martin,
please.
okay, Frank,
Yes.
Yes,
Caroline,
please.
okay, and the rest. We are all fine. Okay, especially Prof. Jermaine. Are you fine? John Jermaine. JJ, are you there? Are you fine? Oops. Okay. All right. So on this note, or at this point, we are going to have our water break. When we come back, then we go and look at the next set of what questions. So welcome back from the water break. Okay, so we are looking at our next set of questions. Okay, again, we are asked to differentiate the following function from the first principle. Okay, look at the first set. We're looking at linear functions. So if you like, let's go back and see. Okay, the first set, the functions were linear function, the highest power of your variable x. Okay, however, this time around, you can see that we are dealing with quadratic functions. Okay, the concept is basically the same. We're only that when it is quadratic, okay, you are going to work more, a little more. That's all, because there will be expansion based on the powers. Okay, as simple as that. But the same concept that we are going to use. Okay, so here we go. Okay, so solution differentiate from the first principle. So we underline. If you use any other approach, you'll be rather than the approach that we are going to use. Okay, so major question number will be 2. Minor question number I. Okay, then what are we giving? Y is equal to what? X squared. Okay, so we need to differentiate this one with respect to what? X. I mean, from the first principle, because Y depends on X. So we are finding d dx of Y. So it means if I'm quoting, I'll write dy, okay, dx, okay, is equal to then the limit. Is that clear, my professors?
Yes, please.
Okay, as h approaches 0. Okay, now you know the formula. So let's go the whole class. The formula f of
F of
x plus
f
a
of x plus 8 minus
minus,
f of x over h.
okay, all on h. Okay, so now that we know the formula, we are good to go. Okay, so let me disable my notations. Okay, all right, so this is what we have. Okay, so at this point, we allow the formula to talk to us. Okay, in the formula, as you know f of s, as you know f of s plus h, Do I know f of x directly? No. But indirectly, I know that y is the same as f of x. So I have to go and carry out that representation. So I'll write let. I hope you are following my professors. Oops. Oh,
Yes.
what happened?
Yes, please.
Okay. Okay, so we are going to get what? Let f of x
F of x be equal to y.
be equal to y, but we are mature. We know that y will be equal to s squared, so I can write s squared straight away. All correct.
Yes, please.
Okay, instead of okay. So now I can say that this implies that once I know f of x, I will need f of x plus h. So I can comfortably go and find that. So that will be equal to wherever I see x, I put x plus h there. So it will be s plus h. Okay, then the whole of that squared. My professors, are you with me?
Yes, please.
Hello, Afa.
Yes, please.
Okay, good. All right. So remember, I said don't go and carry out substitution of any of these two functions when you see brackets there. So you always have to expand. Go and put the expanded version, expanded and simplified version. So at the normal circumstance, my equal to should have been here, but I always have to write close to the margin. So equal to. So if you expand this, we know how to expand any binomial square. So mentally, we know this will give us s squared, okay, plus twice the product of this, which will be 2xh, okay, then plus a squared. All correct. So, professors, are you with me?
Yes, please.
Okay.
Yes, please.
I don't think someone would want us to go over this because we did this the very first vacation classes. Remember, we built our foundation algebra, how to expand, how to factorize, and what have you. So we did binomial, okay, expansion to the power 2. Binomial squared, how easily you can expand that. If you can't do it mentally, though, okay, you know it's the same as s plus h multiplying s plus h. So you would now go and distribute, then combine. But you don't do that now. I mean, in Form 2, no. Even Form 1 will allow in SHS, you are matured. So we expect you to use the matured way to expand this. Okay, are we fine? Prof. Frank, I saw your hand up. Or you've had a change of mind.
Please, I'm a bit confused with the x squared turning to the x plus h all squared.
Oh, now you know f of x. Yeah, it's the same thing that so wherever you see x, you put s plus h there. So it's s squared. So it will be, if you put s plus h here, it will be the square will affect your new s, which is s plus h.
Wouldn't that be f of x squared instead?
Wouldn't that be what? F of what?
F of x squared.
Which one will be f of s squared?
I mean, like if you make it f of x squared, wouldn't it be f of x plus h squared?
I don't get you. Please, do you get him?
Yes, sir.
So what is he saying? I don't get him. Prof. Frank, what is the issue? I still don't get you. Wouldn't it be what?
Sir, it's okay.
No, you come. I need to dispel that misconception. I'm
Sir,
interested.
I was trying to say, like, since it's x squared, wouldn't it be rather f into brackets x plus h squared? That to make it x plus h squared. I didn't know, I didn't understand how like the x squared will make it x plus h squared.
Okay, if you have, so that's your problem. Okay, I think we as for functions, we did a lot. So I never envisage we will struggle here, but that's your problem. So let's see. If you have, okay, f of x is equal to x squared. If I ask you to find f of 1, what will you do?
One
Prof.
squared.
Frank, only you.
Please,
What will
one
you
squared.
do? It will give you 1 squared.
Yes, please.
Okay, f of 2. Those who understand, you can continue, then later you cross-check so that you won't be bored. Hey,
Please, 2 squared.
2 squared. Okay, so if I ask you to find f of what, maybe z, what would that be?
Z squared.
Okay, z squared. Okay, so if I have f of x, okay, is equal to s squared plus 1, and I ask you to find f of 1, what would that be?
1 squared plus 1.
1 squared plus 1. F of 2.
2 squared plus 2.
F of w.
Squared plus w squared plus 1.
So f of x plus 1 will be equal to
X plus 1 all squared plus 1.
Then you shouldn't have a problem. Okay, I cast that spirit away now and now. Okay, so this is what you have. So if you know f of x is this, and you are finding f of x, okay, if you've been able to understand this one, then this one should be easy peasy. All right, so if you have f of x and you are finding f of x plus h, it means wherever I see x, I put s plus h there. That's as you were doing here. So this will give us s plus h, then now you square it. When you did the s plus 1, okay, you put it here. Didn't you square that?
Yes, sir.
But here there is nothing being added apart from 0. So you end here, just like this. Apart.
Yes, sir.
So you didn't have a problem. You were trying to find a problem for yourself. All right. Okay, so sorry, can we move on now, professors?
Yes, please.
Okay, so now that we have f of s plus h, we are in a comfortable list. So you go and write therefore what you are asked to find, which is the dy, okay, dx. Okay, will be equal to the limit as h approaches 0 of what? Now our numerator, our f of s plus h will be this 3 terms here. So that will give us s squared. Here, let's go.
Plus 2xh plus h
sh plus h squared, then minus f of s, which is a
minus
monomial.
x squared.
So you can choose not to put it in brackets. So s squared all over h. Afa.
Yes, please.
Okay, my professors, is everyone fine at this stage?
Yes, sir.
Okay, so let me come and clear this. Okay. Prof. Frank, APK.
Yes, please.
Okay, good. All right. Okay, so now let's go and look at the continuation quickly. Okay, from
Sir,
yes, please. Okay, who was that?
it's a polynomial.
Prof. Echo, what is it?
That means he said, since it's a polynomial.
Hey, did I say polynomial?
Yes, sir.
Please,
He said
did you say
monomial.
polynomial?
Monomial, not polynomial.
Binomial.
Okay, because I was wondering. So I thought Echo, you were hearing voices. Okay, so they've been able to connect. Okay, so monomial meaning an expression with one term. The bracket can go. Okay, but you can still put it in brackets. Only that if you put it in bracket, we'll know that maybe you are playing it safe. But that will indirectly disclose your immaturity as well.
Okay, sir. So I wanted to know what you were saying.
You wanted to know?
What you were referring to.
So I was referring to, so I said since f of x is a monomial is a one term, so the bracket will not be necessary. You saw that in the previous one. Okay, here it was a binomial more, so the bracket was necessary more than a monomial. Is it clear now? Just like this
Yes,
one.
sir.
So take note of that. Okay. All right. So, okay. So that's what I meant. If you are fine, then we can proceed. Okay. So this will be equal to my next step. Okay. I would have written equal to here. I'll write it close to the margin. So that will give us, okay, again, you write the limit. Okay. As h approaches 0, of what will be our numerator. Okay.
2x
Okay, so s squared will cancel this s squared. So you'll be left with these two terms, the two middle terms. So you are going to get what? 2x8 plus what? A squared all over h apart.
Yes, please.
Okay, so now here you need to listen. That's for limits there. We are all experts. We should be experts, apart from those who joined late. Maybe the weekend and okay, yesterday. All right, and they have given them the video also to watch to catch up. Anyway, so here, let's see. You can see that after expanding, simplifying, okay, the other one, Okay, we didn't ask. We saw that the H vanished. So there was no need to carry out any substitution for H or ask this question. So let's see. With this one, are we able to directly substitute for H? I'm finding limits of a rational function. If you directly substitute for H, the denominator will be 0. And remember, we said if the denominator gives you 0, it tells you that you can't do direct substitution. Okay,
Yes,
so what do
please.
we do? We need to go and manipulate. And the manipulation techniques that I told you or I taught you, okay, factorization and what? Rationalization. No set involved, so rationalization should be out. So we settle on factorization. So we can factorize the numerator. We can bring h out. Is that not it?
Yes, please.
Okay, so
Yes.
now I will write the limit as h approaches 0. Okay, of my numerator, I can factor out h, then I'll end up getting 2x plus
Yes,
h. Is everyone
H.
okay?
Yes, please.
Yes,
For my
please.
denominator h. So this h will cancel that h. Okay, but I'm not going to show the cancellation. Okay, Prof. Gideon.
So please, but in the factorization, can you bring the 2x plus h squared out
You
and
can bring what
factorize it as
out?
well? The 2x plus h squared. So you can factorize it and get the h, or you can just go straight ahead with that, with this kind of factorization.
No, how are you going to factorize?
Also, please, I didn't mean like complete factorization. Yeah, you're just bringing the h out.
So anytime I've told you, anytime when I taught you factor, Gideon, they tell you that you are okay, a pioneer. Okay, so when I taught you factorization, I told you that two basic questions that you ask yourself first before you think about any other technique of factorization. Do I have a common number apart from one that can be brought out? Do I have a common variable that I can bring out? Okay, I do. Okay, if I bring it out, I check whether the other factors that I have there, they are still factorable. If factorable and I have to resort to any of the factorization skills, I do. But here, any common number, no, apart from one. Any common variable letter, yes, h. So I brought h out, and that ended up with this. So this is factorized completely. I cannot factorize this. I can't factorize this. Is that clear? So the fact
Yes,
that you
sir.
see quadratic here with the a squared doesn't mean you should go and use the quadratic. You get it?
Answer please. I was not referring to the quadratic. I was I was asking if you could just bring the 2x plus h squared out. If you can bring it beside, like as your rough work, at the right side, and then
Okay, I do get you. You want to take it out, go and factorize and bring it there.
yes, yeah, but I was asking if you can do
Yeah,
that in
remember
this bracket.
what? Please, can someone tell me the advice? Okay, that I gave you for the circumstance where you are supposed to take it out and go and factorize and bring. Okay, import your result. What did I say? And what circumstance did you do that? Or do you do that? Under what circumstance are you supposed to do that? Our professors, who will make me proud?
Please, you
Okay,
said
Prof. Benji.
when
Say if the methods are like you won't use a lot of simplification, then
I do get you. Okay, I'll fix in the missing link. Okay, when the factorization steps, okay, is more than one. So that's what it means. It's more you need. But here, the factorization will involve only with just one step. I'm done with the factorization. So it's not necessary to import. Go and factorize and import. Is that clear? Or Benji?
yes, sir.
Okay, so no necessary to take it in this circumstance. So, like I always say, okay, the young will know the rules, but the elderly and the wise will always know the exceptions. Okay, that's why always I give you the exceptions. Okay, so in this case, what do we do? Okay, we know this will cancel that. So we are going to get the limit. Okay, as h approaches 0, okay, of what? 2x, okay, plus h. Am I right?
No, say
Yes.
Okay, what is missing?
It's a
bracket.
bracket.
The bracket. Hey, this shows that you are learning. I like that. Okay, Prof. Martin.
Sir, please, this is a question.
Okay, go ahead.
Where you said from the limits, when we reach that stage where it's either factorization or let's say
Rationalization.
rationalization.
Mhm.
Can it be that maybe I can use the normal fraction method where, like on this one, where I separate those two and I
Oh
get
no, that one you
2x
write
cubed
it more.
over each?
You've never done that. You are now going to write this over that, this over that. You write more, and you still have to introduce bracket. So don't do that. Just factorize, please.
Yes, please.
Okay, we've never done that. Okay, I knew you, but you don't do that. Just factorize. You know the limit so far, rational function. Okay, we factorize and deal with what was not allowing direct substitution. Okay, and that's what we have done here. So at this point,
Yes.
what do we do next? This will be equal to, okay, so we are going to have, okay, now a limit of a polynomial function. So you can do your direct substitutions. That will give us 2x plus 0, which in effect will give us 2x. All correct.
Yes, please.
Now, Professor, is everyone clear? Are we fine?
Yes, please.
Sure.
Yes, please.
Okay, so
Yes,
looking at
please.
the time, most likely, okay, wouldn't be able to do the marking. Okay, but I will tell you what I will do to cater for that. Okay, to do the marking together as a class. So I think it will give us more room to, okay, solve for at least one more question. Okay, then okay, at least you need to get it the best time. Okay, maybe we can continue. Let me see. Okay, so I can end here, Abby. So that next time you continue, at least. I can end here, right?
Yes, please.
Okay, so
Um,
let me end here so that those who would want to go over and okay, catch up, you can catch up.
so please, I wanted to capture the picture.
Hey, all right, so you let me end, then I will go back for you to capture. Okay, so that the video will not take off. Okay, so at this point, okay, the next meeting will be, I'm going to end here. The next meeting will continue from where we left off, and that's what will be Friday, okay, God willing. Okay, so thank you very much for your time, for making the class very interactive as usual. Don't forget to subscribe, like, and share. May the good Lord, okay, bless us all.